Again, welcome to today's webinar, Test Android and iOS Apps on Real Devices with AWS Device Farm. Our presenter today is Trent Peterson. Trent is the product manager for AWS Device Farm, a mobile app testing platform that helps developers automatically test their apps on hundreds of real devices in minutes, catching issues before they're released into the wild. He joined AWS through the acquisition of AppThwack, an app testing company he co-founded. Prior to AppThwack, he was in Intel Design System Automation Solutions, trusted to test products used by millions of customers with an emphasis on simplicity and user experience. Also with us today, we have Nikhil Dapade and Andrew Hawker, who will be our webinar moderators answering your questions throughout the presentation. Trent, welcome. The floor is now yours.
Great. Thanks, Heather. And thank you all for joining us this morning to learn more about how you can use Device Farm to improve the quality of your mobile applications. So before we jump in, let's talk a little bit about why AWS built Device Farm in the first place. So as mobile app developers, you're probably well aware that it is a very competitive market out there. There are over 4 million mobile applications. That's just in the Play Store and Apple Store combined. That doesn't count internal applications and so on. Now, that's great for consumers because it gives them lots of choice, but from a developer standpoint, it can be fairly challenging, especially the fact that consumers have a voice and can air their grievances or their praise through reviews, and those can really make or break an application. Now, why do applications get these positive or negative reviews? Many of them relate to the quality of the application, and the quality of the application is a challenge for mobile development, and that's because we're talking about many device form factors. So we have phones, we have tablets, we have TVs and set-top boxes and so on that are running these operating systems. And consumers have an expectation that their experience will be consistent and in line with their desires regardless of the platform that they happen to be using. So if they're using a phone in their day-to-day, they go home and they pick up a tablet, they get in front of the TV, that experience follows them and performs to their expectations. Now from a development standpoint, this isn't just form factors and screen sizes. This is also things like devices, hardware, and so different Bluetooth stacks. We have different carrier and manufacturers making modifications to the kernel and to the firmware. And we have environmental factors. So our customers could be, on a connection that's inconsistent. They might be on a good connection 1 minute and on a poor connection the next. And so all of that can affect their experience within your mobile application and can eventually lead to a positive or a negative review. And so we built Device Farm to help developers battle this challenge, or to solve this challenge with mobile application quality. And so when we talk to developers, what we learn is that the device cabinet is somewhat ubiquitous. So as mobile developers, you probably have a stack of devices on your desk or a cupboard somewhere, or if you're in a larger company, you may have a device lab or multiple device labs. And with these device collections, there's not just the challenge of keeping up with it and buying more hardware. There's also upkeep, maintenance, keeping track of where they are and who's using them. Do we have enough of them for all of the developers? And then there's also, how do you actually use all these devices? So with 1 or 2, it might be manageable to plug it into your local machine or tap along and do some manual test execution. But at scale, there's the need for automation. And when you have automation in many, many devices, there's a challenge of actually building the infrastructure to execute tests on all of those devices, and then what do you do with the actual results and how do you interpret them? And so with that challenge in mind, we thought that AWS would be a good fit for this because we can take on that scalability challenge on behalf of developers and free you up to work on the things that really matter, delighting your customers. So in today's webinar, we'll be going over an overview of what Device Farm is and what it can offer. We'll spend quite a bit of the time in a demonstration where I'll actually show you what Device Farm does, and we'll execute a test, we'll interpret a report, we'll manually interact with the device, and so on. I'll do a brief demonstration of how you can then use Device Farm as part of your continuous delivery and continuous integration story. And finally, we'll wrap up with Q&A. And a note about Q&A, of course, you can ask questions throughout the session, and the moderators will attempt to answer your questions as best they can. So what is Device Farm? So Device Farm allows you to test Android and iOS devices. And the types of applications that you can upload to us are native applications, so think Objective-C and Java applications. Also hybrid applications, so applications built in frameworks like Unity, Xamarin, and so on. And also web applications that you can test in Chrome and Safari on Android and iOS respectively. With Device Farm, you get a scale that is very difficult to achieve with a local lab. And what this means is that you have hundreds of devices to choose from. And when we say devices, I mean a manufacturer, a model, and an operating system version and a carrier variant. So for instance, a T-Mobile flavor of the Samsung Galaxy S6 running 601 would be a specific device that you can choose to run your tests on. Now behind each of those devices that you see, so you have hundreds to choose from, there are many, many instances of each to accommodate your demand. So that you can be sure that when you schedule a test on Device Farm, that those devices will be available in a timely manner. Security. So Device Farm was built with security in mind from the ground up. So on the hardware side, what this means is that devices are physically isolated from one another. So devices are actually stored in containers that prevent them from seeing each other. So a device can't record video or audio or take pictures of any other devices in our data centers. It also means that the devices can't see each other wirelessly. So a device will not sniff the traffic or connect to Wi-Fi that another device is connected to. And speaking of Wi-Fi, every device has an internet connection that allows it to communicate out of Device Farm. So your application can make use of external systems. There is no public IP, so there's no way to come back into the device. And each of those devices' Wi-Fi connections is unique. So there are not devices on a shared network. There's no concept of a LAN in Device Farm. The device has a dedicated Wi-Fi connection that only it can see, and that is how it communicates with the outside world. Now, that device is, of course, tethered to a host machine. So if you're running tests locally, or if you're familiar with debugging mobile applications in a local environment, you're familiar with plugging your device into your laptop or your machine and debugging from there. So similarly, on Device Farm, when you upload your app and you start running your tests are running on a device that is tethered to a host machine. That host machine is brought up dynamically exclusively for your tests, and when your tests are finished with their execution, that host machine is torn down. So your test code is not executing on a host machine that has been used before by other customers or even yourself. So when we talk about flexibility in Device Farm, what we mean is that regardless of the type of test you want to execute, so if you're running automated tests, and those could be functional tests, those could be stress tests and performance tests, whatever they happen to be, you can run them at scale in parallel on many devices at once in Device Farm. And regardless of the framework you've chosen, there's a high likelihood that you can run it on Device Farm. So for instance, on the Android side, we support Calabash instrumentation, which includes Robotium and Espresso. We also support multiple flavors of Appium, so Appium Python, Java, Java Test and G. And on the iOS side, similarly, we support flavors of Appium, we support Calabash, XCTest and XCTest UI, and so on. And when we get into the demo, I'll show you where you would configure these. Now, also, if you don't have automation, if you don't have automated tests written today, we have a couple built-in tests that you can use. So you can actually get started with Device Farm and run automated tests without writing a single line of code. So we have an Explorer that we'll talk about a little bit later that will walk or crawl through your application and take pictures in a video as it goes through it. We also have a fuzz test that will hit your application with random input in a highly rapid fashion. Now, if you are looking to interact with a device directly, so maybe you're doing manual test execution, or you have a report from the field and you're trying to reproduce a customer issue, or you're even on the phone with a customer and you need to reproduce an issue, you can use our remote access capability. And what that does is it allows you to actually reserve a device and interact with it through your browser in a manual fashion. And out the other side, you'll get logs and you'll get a video of your session. So speaking of those automated tests and your manual sessions and videos and so on, now the true value in Device Farm is that it gives you a report that allows you to zero in on trouble and problem areas. So those reports are going to include high-level results, so pass, fail, passes, pass, fails, errors, and so on, and the counts. It's also going to give you a video recording of every single test. It's going to give you screenshots, and if you've written your own automation, you can actually trigger when those screenshots are taken, and we'll take care of collecting them for you. You're going to get logs, so that's low-level logs like Logcat and device logs on Android and iOS, and performance data, so things like memory usage, thread counts, and so on. And we take all of that from all of the devices you've selected, and we package it up into a report, and you can go through it in your in the browser. Now, I mentioned before that we'll talk about Jenkins in a little bit. We have official plugins for Jenkins and Android Studio, or Gradle, that allow you to kick tests off automatically as part of your continuous delivery story. So right from within Android Studio, you can click a button that says Run Tests on AWS Device Farm, and your test will start running in the cloud. We also have Device Farm APIs exposed through the AWS SDKs. So regardless of the tool set you happen to be using, you can integrate Device Farm capabilities into your workflow. And similarly to the SDKs, we also offer a CLI. So the report that I mentioned before, when you look at it in the console and when we go through the demo, you'll see that it's an aggregator report, and you can drill down into it and so on. All of the pieces that you see today and all of the functionality you see in our console, that's all done with the same API that we offer through our SDKs. So every log, every video, every screenshot, you can actually get on a very granular level right through our API. And before we jump into the demo, we'll talk a little bit about pricing. So pricing starts at $250 per month for unlimited testing. What this means is you effectively purchase concurrency. So we sell device slots for $250 each per month. If you, say, buy 5 Android device slots, you schedule a test on 10 devices. It will run up to 5 at a time until all the tests have executed. So in that example, it would run 5, and then it would run another 5, and you would get your results. You can schedule as many tests and runs as you would like at any given time. Your test execution concurrency will just be limited to the amount of slots you've purchased. Or you can pay as you go. And so if you aren't ready for the level of testing, if you're not using continuous delivery, it might behoove you to use 17 cents per minute, just pay as you go, no commitment, no upfront fees or anything like that. And after today's session, you can start with 250 minutes for free, so you can kick the tires and see how Device Farm can help you. So Device Farm was launched in July of 2015, so we've had Device Farm as a publicly offered service for over a year. It's offered in the US West region, however, it's available globally. So we have customers all over the world using our fleet of devices in our service. The devices just happen to be hosted in US West. And when we talk about the devices are not just North American devices, so we have devices from other markets, so India and China, for example. And even though those devices are located in the US, we have that international offering. And when we talk about the options available to you when you schedule your tests, there's also a way for you to virtually place devices elsewhere in the world. And you can find Device Farm under the mobile section in the AWS console. And right before we jump into the demo, we'll talk about a few high-level use cases that we see developers using Device Farm for. So the first one is just testing iterative changes. So while you're implementing new functionality, you might open up a remote access session and upload a test build or a debug build of your application. Or you might have a set of smoke tests or regression tests that you run before you push a commit. So we see developers doing that kind of activity on Device Farm. We also see developers using Jenkins or Bamboo or other CI tools to test nightlies or per commit builds on Device Farm. There's also So you might have Device Farm running as part of your continuous delivery story. You might be running on 10, 20 devices on a regular basis, a smaller section of your tests. As you approach release, we oftentimes see developers fanning out that execution to a larger audience, so running on perhaps all 200 Android devices and running a full regression suite as they approach launch of their application. There's also a use case for canaries. So we have developers that are running tests on an hourly or even up to like 15-minute basis, running a small set of tests that simply verify whether their application and backend systems are working properly with expected latencies. And if anything appears out of the ordinary between those canary runs, they will alert the necessary developers so that they can investigate and figure out what's happening, hopefully before they have an actual incident that their customers are impacted by. And finally, reproducing issues. So this is usually done through our remote access capabilities. This is where a customer calls in or reports an issue. This feature allows you to reproduce those issues in a manual fashion, and we'll go through that in the demo. And speaking of the demo, we'll hop over to a browser. Okay, so we're now looking at the AWS console, and you can see here I've recently used Device Farm, so we'll go ahead and jump right into Device Farm. So when you first visit Device Farm, it's going to prompt you to create a project, and a project in Device Farm is simply a logical way for you to contain your uploaded applications, your uploaded tests, and your test results. And so we see some developers using projects for differentiation between various titles that they might maintain. Sometimes a single title will have multiple projects, so there might be an Android project, an iOS project, or a nightly regression project, and so on. It's completely up to you how you organize it. You can mix and match the types of apps and types of tests that you run within a project. It's just a container for your convenience. So for today's demo, we'll go ahead and jump into that project. And so as you can see, when we first visit the project, we don't have actually any test runs yet. This is a brand new project that I created today. So the first thing that we're going to do is create a new run. And now a run in Device Farm is a particular build of your application, a specific test package that you've uploaded to us, the configuration for those tests, the devices you'd like to run on, the configuration for those devices, and then once your run is completed, the run will actually contain the results. So let's go ahead and walk through creating a new test run. So the first thing we do is select the type of run we want to create. And so I mentioned before that we have support for Android and iOS application testing as well as web. So for today's demo, we will actually test a native application that we've written. So we have the option of selecting a uploaded file that we've uploaded previously, or we can upload a file from right here. So I'll go ahead and select a file to upload. And while that's processing, I'll mention a little bit about the application that we upload does not have to be instrumented in any way. So that binary that I uploaded, this APK, I didn't have to instrument it, include any SDKs or any libraries. It's simply the same APK that I would have used to test locally or even pushed off to beta testers or published to the market. And the same goes for both iOS and Android. There's no modification to your application necessary to run on Device Farm. So once we've uploaded our application, you can see it's been processed and we display some metadata about it so you can be sure that the application is being processed correctly on the Device Farm side, as well as the fact that you've uploaded the proper binary. The second step is to configure a test. So I mentioned before that we support a number of automation frameworks, so things like UI Automator, instrumentation, Calabash, and so on, and also these built-in tests that you don't have to write any scripts for. So the built-in Explorer and the built-in fuzz test. And each of these has a number of parameters that you can specify. So for example, the Explorer, you can specify a username and password. When the Explorer comes across a login screen within your application, it will attempt to use these supplied credentials to get past that screen. For today's demo, I have instrumentation tests. So again, similarly, we can select a previously uploaded set of tests, or we can upload one on the fly. And similar to the app that I uploaded, I did not have to modify these tests in any way. So the idea here is that you can take the same binary and same tests that you're running locally and run those on Device Farm. One thing to keep in mind is that when you run on Device Farm, you will typically be running on devices that you've not actually run on before. So automation, if it's not written to be opportunistic, it can become somewhat fragile when it's running on very low-end devices or very high-end devices and run into timing issues. So when you're developing your automated test scripts, it's important to consider the fact that hard-coded waits, for instance, are probably not the best practice, and instead you should wait for elements to appear in an opportunistic fashion so that your tests will be robust enough to handle the many devices that your application will run on in Device Farm. So then the next step is to select a device. And it's not just select a device, we actually select a device pool, and a device pool allows you to specify a collection of devices. So by default here it's selected the top device pool, which is a curated pool that we maintain. That pool has 5 devices within it, and as you can see we're compatible with all 5 of these devices. Now you can create your own device pool, and this is where you'll see the hundreds of devices that I mentioned before. So for instance, we could say that we want to test on all Samsung devices, for instance, or specific ASUS devices. Also, you can specify a device pool using rules. So for instance, you can specify that you only are interested in tablets, and you're only interested in Samsung. And so now you can see that it's auto-selected all of the Samsung tablets that are available on Device Farm. And now when you create a device pool using rules like this, we're deploying devices and making new devices available on a week-by-week basis through Device Farm. And by using rules, you don't have to maintain your device pool. If you're always interested in a specific type of device, and say next week a new one comes out, and we deploy it to the fleet, your pool will automatically update and contain that device, and your test will run on those new devices. So for today's demo, we'll go ahead and use the default pool. And the last step here before we go ahead and run is to specify the device's state. And so this allows you to specify things like extra data. So extra data allows you to upload a zip file containing arbitrary data. So if your application or tests consume media files, or they need a test database or test information, this zip file can contain that data. On Android, we'll unzip this to external data, and on iOS, we'll put this into your application sandbox so that your tests and application can make use of that data. You can also specify the installation of other applications. So you can upload one or more additional applications that will be installed on the device before your application under test. So that application we uploaded in step 1 will be installed after these other applications. You can also specify the order in which these other applications will be installed. And so through this, you can test things like dependencies or integrations with other apps. You can also test upgrade flows. So for instance, you could upload a previous build of your application in this step. That will be installed first, and then your application under test, the new build, will be installed over the top of it. You can also specify the radio states of the device. And so you can do this from, if you have the permissions within your test and application, you can actually do this programmatically, so disabling things like Wi-Fi while your test is running. This functionality allows you to do this before your app actually launches for the first time. So before your test and app have even run, you can disable these radio states and test how your application will perform in those scenarios. Next up, you can specify the device's location. So I mentioned that the devices are physically located in US West region. However, you can specify the latitude, longitude, and the GPS on the device will be overridden, and your application, if it reads the location, will see that the device is in your specified spot. So you can test things like geofencing and other location-based functionality of your app. And finally, you can test localization by specifying the language and dialect that will be set on the device. Okay, and everything looks good. We do a quick review, and we'll go ahead and start the run. And so you can see here that we now have a new run in our list. It says that it's in the scheduling state. And as soon as any of those devices that we've scheduled on become available, it will go into the running state, and you can see now that it's spinning. So we found some of the devices. Let's go ahead and take a look. Okay, it looks like 3 of the 5 devices so far have been found and tests are actually executing. So I mentioned before, behind every device in the fleet we have many instances so that when you select those devices, your test will start running in a timely fashion. It's also important to note here that we don't wait for all devices to be available to start running your tests. The same goes for the actual results. So as these devices complete their test execution, the results will be pulled in, this report will start to generate, and you'll get the results as they come in. So you don't have to wait until all tests are completed to actually see those results. Okay, so real quick, the one other thing, so while that's executing, we'll go ahead and schedule a remote access session, and then we'll go through a report. So remote access is the manual interaction that I mentioned before. So to start a new session here, first we select a device. So you can see we have a number of Android and iOS devices available. We'll go ahead and select a device to run on. We can specify a session name, or we can just use the default, which is the device we've selected. And we confirm and we start. And now that we've made the request, we can see that we were waiting for this device to become available. One has already been found, and so now it's being configured and set up for our session. And this can take a couple minutes. We do a number of steps to prepare the device and make sure that it's in a state, in a healthy state, and this goes for both automated testing and for manual testing. We do a number of steps to make sure that that your application will run on a clean environment and have a Wi-Fi connection and so on. So that you don't have to worry about inconsistencies from run to run or session to session. And I'll also mention here that when your testing is completed, you'll see a test in your report that's called a teardown test. A teardown test is going to uninstall your application, reset a number of things on the device, clear external memory, and so on. And that clears your IP off that device before it's ever moved to another developer. If any of those steps happen to fail, then that device is going to be quarantined. And we will attempt to recover the device and figure out what went wrong and why we weren't able to clean it successfully. If we're unable to clean it, the device is actually destroyed. So you can rest assured that your IP is not left behind and available to another customer. Okay, so as you can see, the session has started here for our session, so we can actually interact with the device. So you can see I'm gesturing. And so on. So you interact with it, it's responsive, you can reproduce customer issues. We can also say that the application that we just uploaded for our automated run that we just created, you can see that here's that same application. You can see that it was just added. We can go ahead and select that. It'll now be installed on this device and we can interact with it manually. And so on. You can also do things like switch the device's mode to landscape or portrait. You have a number of device controls here. As you can see, it's responsive. Here's the application we just installed. So this is the same test that same application that we're testing over there in our automated run. Here you can see it on the device in a manual fashion. And when we're done, we simply stop the session. And once it's done being processed, there will be a report generated. And so now let's talk a few minutes about what is in a Device Farm report. So first, we'll go ahead and look at an automated test report. So, and the reports between automated tests and for remote access sessions are very similar. So the types of data we're pulling out are similar. So we'll look at an automated test run because there's a little bit more to it. So this is a test run that was completed earlier. And so you can see here that we have these high-level pass-fails, counts, and so on. So we can go ahead and jump into this report. And again, we see how many tests passed, how many tests failed, and so on. The next section is unique problems. And unique problems allows you to see where errors are concentrated. So even though you had 21 failures, only 13 of them were unique. You can actually see that one of them appeared 6 different times. So the idea here is that by addressing it in one of these locations, you'll likely address it for all 6 of those test failures. And you can see that it descends here. There's another error here that occurred 3 times, a failure that occurred 2 times, and then a handful of one-offs. From here, you can actually click on a test that has failed, and jump straight to the report. So now you can see here in the breadcrumbs that we're looking at the Samsung Galaxy S6 Verizon variant and a specific test suite. This is the checkbox test, and we're testing the sanity. Down below here we have logs, and I mentioned before that we're capturing Logcat for Android. So here are the Logcat, and you can actually filter right here within the console. You can also download these logs for local analysis. We also have a screenshots tab, and this test actually failed before it ever caught anything, before it took any screenshots. We also have performance data and a number of files, so we can actually see what's going on. So beyond just looking at the failures, you can also look at all tests on all devices. So we can go ahead and jump into, for instance, the LG G Pad here. And we can see a list of all of the test suites. And you'll see that that view that we were looking at before that was specific to a test was very similar to now the view just for a specific device. So as you drill deeper down, the types of data available to you remain consistent. It's just the scope of that data adjusts as you dig deeper. So this current view is going to show you all of the test suites that were executed on this device. And the logs here at the bottom are all of the logs across all of those devices that ran your tests. And the same goes for screenshots. So if we switch over to the screenshots tab, we can now see all of the screenshots across all of the tests that were run within that device. Performance is the same way. We can see memory and thread counts of CPU usage for the entire duration of our tests. And on the final tab, we can see all of the files. So let's actually look at one of these test suites. So we'll go ahead and go to this. This test is checking if the camera is on. We can go ahead and click on the video. And there you go. So that was a video recording of that test being executed, and you can see that it popped up the application, did a number of steps, and this test happened to pass. You can also download the raw Logcat, so if you're using local analysis, you can do so here. One other thing to mention is that all of these files, I think as I mentioned before, all of these files and all of the data that you see on the screen you can actually pull programmatically. So if you want to archive Logcat, for instance, you can do so, and you don't need to go into the console and do it yourself. Okay. One other thing to mention here is that you can manage your device slots, manage your uploaded files. So here are the uploads that we've uploaded. You can manage them here. You can delete them. You can also upload additional files here. So if you're working on it as a team, you might have a single person responsible for uploading files, or you might programmatically upload files, and you can manage those here. And that's applications, test packages, and so on. You can also create new device pools from this view, so you don't need to go through that run wizard that we did before. You can do so straight here from the settings, manage your device pools. So again, in a team setting, this is especially useful because you might have one person responsible for maintaining the device pool, the uploaded files, and so on, and then everybody that's using sessions and using remote, using automated testing can make use of those device pools and files. Okay, and with that, we will switch back over to the presentation. Okay, so let's talk a little bit about continuous integration. So everything I just showed you was, of course, we were manually interacting with the console, kicking off tests, kicking off sessions, reviewing reports. Now, as I mentioned before, we have official plugins for Gradle and Jenkins, and through the Gradle plugin, you can use Device Farm right from within Android Studio. So I'll give you a demonstration of that Jenkins plugin here in a moment. In addition to those plugins, we also have a CLI. So through that CLI, you can kick off tests just from your terminal, pull down results, and so on. And finally, you can use SDKs. So as I mentioned before, we have SDKs for a number of popular languages. So regardless of the tool set you're using, you should be able to use Device Farm capabilities within those tools by using these SDKs and CLI. we're resharing my machine. Okay. So now we're looking at a Jenkins, a local installation of Jenkins that I have. So if you're familiar with Jenkins, you'd be familiar with this view. I have a couple projects here. So I'll go ahead and jump into my Android app. And one thing to note is installing our plugin is very easy. You can do so if you go into Manage Jenkins, go to the plugins. You can find our plugin if you just type in AWS Device Farm. You'll see our plugin there and you can install it in a single click. Of course, you can also pull down the code. It's available on GitHub and you can build it locally. So we'll go ahead and jump into one of these projects. So I have an Android project set up, and you can see here that right here within Jenkins we have a Device Farm section, and you can see that there is a number of builds that have been tested on Device Farm. And next to each of those you can see how many tests passed and failed and so on. There's also a link here to jump to the full report within the console, so that report that we just walked through a couple minutes ago. You can also see trends from build to build with your tests, how many are passing and failing, and through that identify trends and see where problem areas might exist. So one quick note is that when you configure Device Farm for Jenkins, you can configure it as a PostBuild Action. And so what this means is it allows you to run Device Farm somewhere in your continuous integration flow, and then you can choose to have this actually fail your build, and it's completely up to you how you want to do that. You can specify the project within Device Farm, so you can see here it's specifying that project we were just in. You specify the device pool, a path to where your application will be contained. You can also specify a build or the run name, and you can use variables like build tag, so you can actually name the runs after this particular build in Jenkins. You can specify which type of test you'd like to run, the associated parameters, where to find the test package, and so on. So pretty much everything that we just went through in the wizard, you can do so from the Jenkins plugin. So let's actually go ahead and kick off a test manually. So of course, being Jenkins, you could have builds triggered based on commits or whatever you'd like. In this local instance, I just have it so that I just manually kick them off. It's completely up to you. So you can see now we have an active build. And you can actually see now over here in the console, we can actually see that there is a Jenkins run now scheduled. And you can see that it's running on a handful of devices already. And you also likely noted that tests that we started running earlier, those are also still executing. The test package that we ran actually takes about 15 minutes per device to run. So we won't sit here and wait for all of those results to come back in. But you can see that we're actually executing on multiple sets of devices across multiple builds at the exact same time within Device Farm. Okay, and with that, we will jump back over to the presentation. Okay, so thank you for joining, everybody. The deck will be available after today's session. We'll go ahead and do Q&A now, and I will just answer questions on the fly. We will also share a number of helpful links for you to access Device Farm, also documentation. That sample application and the tests that we uploaded through the demo today are actually available on GitHub for you. We have a sample app for both iOS and Android and web. And we have sample tests written in a number of the frameworks that we support that take advantage of all the capabilities that Device Farm has. So things like location, if you want to test the location, latitude and longitude, there's a test that will help you implement that in your own tests for your own app. So all of that's available to you, and we'll send that out afterwards. So we'll go ahead and jump into Q&A. And one quick note here is that if you're interested in learning more, we have Dev Days coming up Monday, October 24th. And if you're interested, I invite you to check it out. And with that, we will do Q&A.
And I'll just jump in for a moment and point out that we do have our poll questions available for the audience members to vote on right now. So please do provide us with your feedback by clicking the radio button next to the reply. And it looks like we do have about 15 minutes left, so please feel free to continue submitting questions. Thank you to Trent for the great presentation and Nikhil and Andrew for all of the questions that they've addressed so far. And now we'll start addressing some of those that have been submitted. So Trent, back to you.
Great, thanks. So we have a question here. So the question is how to see where you are within your account. So if basically how your usage is for a given month or at a given time frame. So how many minutes have you used on Device Farm and so on. So there are a couple ways to accomplish this. One is through the billing console. If you go to the billing console, it will have a breakdown of all of your minutes, and it's actually very granular. So it will tell you how many minutes you've used on iOS. It will tell you how many minutes you used on Android. And not just the billable minutes. So I mentioned before we have pay-as-you-go, that's 17 cents per minute. That will display there. If you have device slots, you'll also see a breakdown of how many minutes you're using for your device slots. Even though those are flat rate and we're not charging you per minute, you can still see how many minutes you've used. That lags actual usage by up to 24 hours. If you're looking for a more real-time metric, every single run or session that you do on Device Farm has a column associated with it, or a set of data associated with it, that actually breaks down your total execution time or total session time, along with how much was actually billed. So if you were the test run that we just scheduled, you would see overall test execution time. Maybe it's 60 minutes across all 5 devices, if it's 15 minutes each. Then you will also see that, okay, there's an overhead for Device Farm that you're not billed for instance, uninstalling your application, cleaning up the device and so on. We don't charge for that, but we do count it towards your execution time so you can see how much overhead Device Farm adds. So you can see all of that information in the console and through our API. There is a question about whether or not you can specify the location in a way that would allow the device to appear to be moving during your test. So we don't expose a method for this through Device Farm. However, you can use it on Android. On Android, I know that this is possible. You can actually create a location provider and do this on the fly during your tests and simulate movement from within your app. So even though we allow you to specify latitude, longitude at the start of your test, you can take that over while your test actually executes. So essentially, the test will start, your device will appear that it's in the location you specified when you scheduled the run, then your test will specify the movement that it should perform, and you will be able to control that movement from your tests. There's a question here on whether or not you can see the test being run on the app at the browser or in your browser. So yes and no. So through automated testing, the answer is no. Today, when you run automated tests, you cannot see the test actually executing in real time. The reason for this today, the design decision was made because most automated test runs are being done on mini devices, and they're being done in an automated fashion through things like CI and continuous delivery. So there's nobody actually there to watch the device. Now, once your test execution is completed, of course, you can watch the video and play that back, go through the logs, and you can replay the events, but there's no way to see it live as it happens. Now, if you're using remote access and you're interacting with the device in a manual fashion, of course, you have live access to the device. So you can see what's happening there and observe it. Now, we're always looking at new ways to help developers with their testing. And feedback like this is helpful for us as we're prioritizing our roadmap. So if live test execution monitoring is something that's important to you, I encourage you to reach out and talk to us, and we'd love to learn more about your use case and how we might address your needs in a future release of Device Farm. So there's a question here about whitelisting devices and whether or not we can guarantee the same devices or IP addresses across test to test. So as you run your tests, whether it would be coming from the same device or the same IP. So specifying device is not something that we offer today. You specify the make, the model, the operating system version, and the carrier variant, and we will find a device that matches that. You can't replay on the exact same hardware necessarily. I mean, there's a chance that it will happen, but you don't specify the exact specific physical instance of a device on Device Farm. As far as internet traffic goes, we do publish a static list of IP addresses that all Device Farm traffic will come through, and you can find that in our FAQ, which I believe is linked in the follow-up email that we will send, or in the deck itself. So you can find that IP range, you can whitelist that IP range, and know that traffic coming from those IPs are coming from devices in Device Farm. There's a question here, do we literally have a big room with all of these different physical devices? So it's a great question. So the devices are in fact physical phones and tablets. Like I mentioned before, they're in containers that keep them physically isolated from one another, and they are in AWS data centers. So I guess the answer is yes, these devices are real, and we do have them in actual data centers. There's a question here about whether or not iOS devices can be accessed remotely. So assuming that you're speaking to the remote access feature where you can interact with devices in a manual fashion, the answer is yes. I selected an Android device during today's demo, but I just as easily could have selected an iPad or an iPhone or an iPod and interacted with it through my browser. So yes, absolutely. And the same kind of report is generated. You're going to get logs, and you'll get a video recording of that session. There's a question here about what is the add extra data used for? So I mentioned during the demonstration that you can upload a zip file containing arbitrary data that will be unzipped to external data on Android or your application sandbox on iOS. So this can be helpful for uploading additional data files. So for instance, if you want to parameterize your tests, maybe you upload a set of test configuration data that your tests consume. You can put that configuration data in that zip file and then consume it on the fly right from the device. If your application uses music files or pictures, or maybe you have a test that wants to validate some sort of image recognition, you can use the camera on the device during your test execution, but due to the way that the devices are stored, your images will be blurry or very dark. The devices can't really see anything. So it might be something that you would be something where you would take the picture, then use a canned photo that you've uploaded through extra data, and do the analysis on that canned photo. And so you can do that through extra data, video files, and so on. It's basically any arbitrary data that your test or your application would like to consume. You can upload those through that functionality. There's a question here whether or not we support Xcode Server. So today we do not support Xcode Server. However, similar to my answer before, we're always listening to feedback. And so if you have a use case here and you'd like to see us add this functionality, please reach out, and we'd love to learn more about what you're trying to do, and again, how we might be able to help you in the future. There's a question here on whether or not we support commercial tools such as HP UFT on Device Farm. And this is an excellent question. Just recently we launched an integration with HP. And if you follow up with us afterwards, we'd be happy to point you in the right direction for that integration. But yes, the answer is yes, we do have integrations with, so today's demo I showed you, those are mostly open source automation frameworks. We do have integrations with commercial tooling as well. There's a question here on whether or not these are real physical phones or virtual software replication. And so it's similar to the data center question. Yes, they are real physical phones and tablets, and I think a quick note here is that these devices are not jailbroken or rooted in any way. These are the exact same devices that you're carrying around, you have in your local test lab, your customers are carrying around, and so on. And we have unlocked versions. We also have carrier-specific versions. So even though we don't have actual carrier connections on the devices, they're all connected via Wi-Fi, we do have the carrier variants because there are modifications, there's pre-installed software that are actually put in place by the carrier. So you can still test on a T-Mobile device, it just won't have a T-Mobile connection. But yes, there are real physical phones and tablets, and we do not have any emulators or simulators in the fleet right now. There's a question on whether or not we have integration with JIRA. So we do not have an official integration with JIRA. However, as I mentioned before, we have a CLI and SDKs. So you could implement this capability on your own. We are always looking at additional plugins to create in an official capacity, similar to how we do Jenkins and Gradle today. So we'll make a note of this, and we've heard customers ask for JIRA support before. It is possible for you to take this on, and if you're interested in learning more about how we've seen people integrate with JIRA, I encourage you to reach out and we can have that conversation about the details. There's a question about what is the difference between the report of an automated test run and a remote control test. So the primary difference is that an automated test run report is going to cover multiple devices, and a remote access session report will only have the device that you happen to use. Otherwise, they both have sort of a high-level result, whether or not it was successful or not. However, in an automated test report, there are actual tests asserting pass or fail, so there are counts and reasons associated with those passes or failures. In a session, there's no real concept of a pass-fail. In a session, it passes if you successfully closed it, and it will have an error status if, for instance, the device malfunctioned in some way, which is not common. The actual data that you get in both of these reports, you'll see logs, so Logcat and device logs for Android and iOS. You also see a video recording. Automated testing today also includes performance data. That is not included in remote access at this time. However, we're continuing to improve our remote access capabilities and adding more useful data to those reports. So for instance, you could actually see performance data once your session completes. There's a question here about iOS 10 support. So we are working on iOS 10 support right now, and it will be available shortly. We attempt to have new OS versions along with new device models available as close to the day of launch as possible. However, due to the security requirements as well as the number of integration points we have, sometimes it takes a little bit longer. So for instance, with iOS 10, we have requirements around video collection and so on that we want to make sure that there's consistency across our entire offering. So it will be available, like I said, shortly, along with Android in. There's a question here on, can you have devices in a private cloud for testing? And so the answer to this is yes, you can. We do have a private device offering. If you're interested in learning more, please contact us, and we'd be happy to talk through your options. But yes, we can deploy a fleet of devices to your specifications. They will be deployed on your behalf in our data centers, and they will be exclusively for your usage. And once your contract is up, those devices will be removed and will not be reused for other customers. There's a question here about how long is the timeout during your test. So today, test execution per device is capped at 60 minutes at a time. So if your tests take more than 60 minutes, we require you to break those tests up and create multiple runs. If your tests take longer than 60 minutes and you cannot break them up, please contact us, and we're looking at offering this in the future, configurable timeouts, and that's something that we could talk to you about. So that we can learn more about what it is that you're doing. Okay, and this will be the last question. And if we didn't make it to your question, I apologize, and we will follow up after the session is completed. There's a question here on whether or not you can use the monkey runner during your Calabash test. And so with Calabash, you have the ability to execute code on both the host machine and the device. And so yes, it is possible for you to kick off the monkey runner from the command line on the host machine from your Calabash test. That's something that was definitely doable. However, it's not something that we offer as a feature. It's just a side effect of that particular framework's capabilities. And with that, I'd like to thank you all for joining us this morning and spending time with us. And I encourage you to try out Device Farm. Again, you get 250 minutes for free to check it out. Contact us if you have any issues, see our forums for common questions, and I hope to see you improving the quality of your app with Device Farm. Thank you very much.
Thank you, Trent, for the great presentation, and Nikhil and Andrew for engaging with our audience throughout the presentation. If you have any comments on our previous and upcoming webinars or suggestions on the topics you wish AWS to cover in future webinars, please feel free to email aws-webcasts@amazon.com. Your feedback will help us to improve our future webinar programming. Thank you to our audience for taking the time to join us today, and enjoy the rest of your day.